If you are into the automotive aftermarket, you have undoubtedly heard of the LS. It's the mythical engine that will destroy anything else out there. But is it really that good? And does it belong in your truck? Well, in this week's episode of Merricks Garage, we're going to talk about what makes this thing so good, because it really is that good. And one of those things is how easy it swaps into your vehicle. We're going to get into motor mounts and front accessory drive and electronics and cover a whole lot of ground here today. So sit tight and let's go get it. Merricks Garage. The LS series of engines is a fantastic upgrade to any old school project running a small block Chevy V8 or pretty much anything out on the market today. It's got great power in a small package and comes with a simple electronic system that really shakes out all of the horsepower in this beautiful block. Today's episode is going to be focused on what you need to know to get this in your truck. We're going to be talking about motor mounts. We're going to be talking about accessory drives, talking about all of the various sensors, what you need, what you don't need, and dispelling some of the myths about the difficulty in getting this thing and getting it tuned. It's an action-packed episode. It's going to give you a blueprint to start on your project. So let's go get it. I got a cool little tidbit of history information for you guys. When the small block Chevy was being replaced years ago and they were looking at their next generation of engines, what was super popular in the market was dual overhead cams. That was where everyone was headed, but GM wasn't really sure that was the direction they wanted to go. So in a very clever twist, they actually built two different engines, one being a dual overhead cam, one being a single cam and block, put them in identical cars, and had their engineers test those cars to see ultimately which engine they preferred. They wouldn't know what was what or which was which, but at the end of the day, when the dust all settled, the venerable push rod V8 was the favorite, and that was what was chosen. And man, a couple decades ago when this thing started production, that was a controversial choice. This is considered an archaic block design, but for good reason. It's been around forever, it continues to work, it's efficient, it makes good power, it's a small package, and by maintaining the shape, it was able to be swapped into hundreds and hundreds of different vehicles. They weren't reinventing the wheel, so to speak. But what they did do is they took all the lessons they learned from the original small block and they poured it into this guy. Just give you a few ideas of the differences, the subtle improvements under the manifolds and the valve covers that you may not see. We'll start right here with these steam ports. You've got two here, and you've got two up here. As the water coolant flows through the water jacket, you're gonna get steam in areas of high heat. So as the coolant evaporates and turns into steam, it's gonna rise to the top part of the engine, and historically that meant these cylinders, particularly this cylinder, got rather hot because as water turns to steam vapor, it loses its ability to cool, and so you end up with a hot pocket right back here, a hot pocket back on the block. So what did GM do to fix that? Well, they put steam vents. These steam vents run all the way along the block and allow steam to exit through the steam port back into your return radiator hose out of the block, keeping the cooling effective and efficient. That in itself was a massive upgrade, but they didn't stop there. A lot of the architecture and design of the original small block, they just improved upon. You'll often hear people talking about a 4-bolt main or a 2-bolt main when they're talking about old school small block Chevys. And that's essentially talking about how many bolts hold on each main cap on the crank. So you've got the crank at the bottom of the engine that the pistons are connected to, and then you've got the cam in the middle that controls the valves. The crank down at the bottom would be held on by 2 bolts. Now, GM saw that the 4-bolt was stronger, and so they naturally did what every red-blooded car-loving guy would do, and they bumped it up to 6. So you now got a 6-bolt main on each of the bearing caps, which is huge. They also dropped the length of the skirt. Now, before you guys think I'm going in a different direction here, let's talk about what the skirt is. The skirt is the actual physical block. So you have the pistons that are traveling up and down within their chambers, but as the piston moves down at the bottom of its stroke, you end up with those piston rings approaching the bottom of the chamber, and without adequate material, you can get slight piston rock, which means as the piston travels down to the bottom, it can deflect ever so slightly, but that micro movement can lead to damage to walls and blow-by and ring damage over thousands and thousands and thousands of miles. It's not really that big of an issue, but it's something that GM wanted to address, and as a result, they made the skirt of the block come down a lot deeper to accommodate and hold that piston more securely. It's little things like that that have really put this engine in the arena of one of the best power plants of all time. I particularly get excited just thinking that the engineers could have gone the other way. We could have had a super complex dual overhead cam that probably made crazy horsepower, but wasn't that easy to work on, was very labor intensive, and had a lot more moving parts. Instead, we basically got the small block Chevy we always wanted, just on steroids. So let's jump into some of these sensors and electronics, and we'll talk about how those electronics have improved the overall performance, efficiency, and reliability of this engine. So I know there's a lot of concern about all the electronics on this thing. I get that. Those are the emails I get about hooking everything up and people worried about making it work properly. And quite honestly, a lot of those people come to me, they've got experience tuning carbs, which is not easy compared to plugging in electrical connections. So let's just talk briefly about what electrical connections you need, what sensors you need, and I'll give my understanding of how those sensors work together to give you more power, because it's not really that complex, and I think people kind of blow it out of proportion in their mindset. When you think about it, what an engine is trying to do is it is moving air through the engine, mixing it with the fuel, and making power. And it has two ways of figuring out how much power it's making. Well, one way particularly, it's going to measure the density of the air, the temperature of the air, the oxygen content of the air coming in, and then it measures as it goes out through your O2 sensor the same parameters. As it compares those two numbers, air coming in, air going out, it can determine how much fuel it's putting in. Am I burning the right amount of fuel? Am I running too rich? Am I running too lean? Is my timing good? Am I sparking too soon, or am I sparking too late? Am I leaving power on the table? Am I running way too rich and wasting gas? The mass airflow sensor and the O2 sensor, or in some cases the speed density and the O2 sensor, take those two things and they come up with a table. That table has all of the spark, the timing, it has all of the fuel ratios all programmed into it, so the engine knows exactly what to do based on RPM, based on throttle position, based on load, all of this stuff. And you don't need to worry about any of this because all of this is handled by the computer. You just need to plug the stuff in. So let's start at the front and move to the back. This is a bare block. I don't have the intake on, so we're gonna have to do some imagining. But let's talk about how the air flows and what the computer is doing during that time. So we talked about the mass airflow. The mass airflow sits in your intake. An important part to recognize about your mass airflow is it needs to have undisturbed air. You cannot have it right behind a 45 degree. You want to have about 6 inches in front of it so that the air can, the turbulence can slow down and dissipate, and you get a nice clean stream of air across that filament in your mass airflow sensor that tells you a ton of information. Oxygen content, temperatures, all that kind of stuff. I'm not going to get into the weeds with it, but it gives you a reading on your temperature and air quality. Then it enters into your intake manifold. Within the intake manifold, there's going to be a couple of things that first it goes through the throttle body. So first it goes into your throttle body after coming through the intake, through the mass airflow. The throttle body will have a couple of sensors on it. It's going to have a throttle position sensor, which is telling how much the valve, the butterfly, is open. So we essentially know how much metered air is coming in. Some of them will have an intake air temperature. Some of them will have a manifold absolute pressure right behind it. And all of these are kind of interchangeable. There's a couple that you really need to worry about that we're going to get into in a minute. But suffice it to say, the throttle position tells how it's metering the air. The mass airflow tells what quality air is coming in. We move into the intake and you've got your manifold absolute pressure. It's measuring vacuum, it's measuring density of that air so that we can make adjustments, or the computer can make adjustments based on what it's seeing. This comes into effect when you're at altitude. Remember rejetting your carb for different altitude? This all happens now automatically. So as the air moves into the intake, before it goes into the runners and down into the combustion chamber, you've got the air coming in. You know what you've got. You're starting to measure its temperature, its density, the throttle position sensor. All of these numbers are getting crunched and dropped into the spreadsheet in the computer. Once it goes into the combustion chambers, you're going to be running off a few different sensors. You're going to be running off your cam position sensor, which is right here, and you're going to be running off your crank position sensor, which is right here. Those two sensors tell us where the piston is exactly in its combustion cycle. If you take the readings off the cam position and the crank position, the engine knows exactly where each individual cylinder is in its combustion cycle, and therefore it can deliver spark, it can deliver fuel, it can advance fuel, it can pull back fuel, it can advance spark, it can pull back spark based on what it's seeing. So cam position sensor, crank position sensor, very important to how that whole thing works. The other thing that is vastly different from what most people are used to with the old school distributor systems is we don't have a distributor anymore. Each individual cylinder will have its own coil pack on it. The coil packs are basically, think of the coil you used to have on your distributor. Each one now, the cylinders have their own. So you get a hotter, fatter spark. You can control that timing even more efficiently because you're not having to run them through different length wires and spark plug wires. So with all that going on, all the timing, all the fueling, everything being figured out, you just get a very efficient burn. The computer is able to tell if it's running too rich or lean, like I said, and correspondingly adjust that accordingly. And then when all of that big bang boom is all gone and it spills out into the exhaust, you have an O2 sensor that's sitting downstream that now takes that data and goes, well, I'm running rich. Maybe I need to pull back my fueling, or maybe I need to pull back my timing. And it will take into consideration all of the various other components that we've talked about, whether it's the air intake temperature, the manifold absolute pressure, and it will make a determination based on that information as to how it needs to run. So it's really not that difficult. We can go off into the weeds and talk about speed density versus mass airflow. They're just different ways of reading air quality in, air quality out. That's all that really matters. We're going to have water temp sensor, we're going to have oil pressure sensor, we're going to have a whole bunch of other sensors that are important. But just remember, crank, cam, mass airflow, throttle, and intake, and your engine will know what to do. So that's it. You don't have to turn your distributor to adjust your timing. You don't have to make sure that the run and the ohm drop on your spark plug wires is going to be adequate for the distance it's going. It's all done for you. The injectors all fire based off the computer. The coils all fire based off the computer. There's nothing to go out of adjustment. It's a very, very awesome system. And quite honestly, one that's really, really easy to work on. But first, we got to get this thing in your truck before you can start doing all that. So let's talk about accessory drive, the transmission, and motor mounts. For about the past 5 years, I've been putting a video out every Friday detailing the lessons I have learned along the way. Lessons involving failure, lessons involving success, and I'm just hoping to pass along all those tips and tricks and shortcuts to you, the subscriber and viewer, so you guys can tackle these projects with confidence and not run into the headaches and roadblocks and dead ends that I did during my process. If this is helpful to you, please consider giving a subscribe down below. And now let's get back to the video. We're very lucky in the fact that the aftermarket support for this engine is phenomenal. So when I start talking about accessory drives and water pumps, recognize there is most likely a solution out there to fit any configuration you can come up with. In Carl's case, it looks like he's gone with a mid-mount accessory drive. You can have a high-mount accessory drive that brings everything up. You can have a low-mount accessory drive that drops like your air conditioner down here and your power steering way down here. Or you can have a mid-mount where everything is kind of kept together in the middle. You don't need to swap out the accessory drive. If you purchased a car and the accessory drive, or purchased an engine and the accessory drive you have fits into your vehicle, then you're good to go. Water pump, crank, power steering, idler, coolant return, alternator, AC over here if you run it. These two lines are for your heater core. So obviously as the water returns, you can have cool water running into here. This is your thermostat. So the thermostat will determine whether this opens and allows water to flow. Water pump is driven off the belt, much like everything else. And that's one belt. You're not dealing with a whole serpentine belt network of multiple belts. You've got one belt that runs the whole thing. And then this is your radiator return. So this is the hot side that goes up to your radiator. Cool side where water comes back in. Power steering down right here. Alternator up here. Now Carl has a alternator. He's got a 4 wire. There are various alternators out there. You'll hear some called 1 wires, 3 wires. Just verify with the computer that you're going to be using what alternator it wants to see. And that's going to be as simple as just looking at the engine, and if it's a stock harness, use the stock alternator with it. Not too difficult. You got your idler pulley here. What else do we have to talk about up front? Well, I mean, there's not a whole lot. This is all pretty simple, pretty straightforward. Should be pretty familiar to those of you. Those of you who've worked on these things. We do have the steam port up here. Underneath this, this is the engine plate to move it around, but underneath this you will have what's called NOx sensors. I deleted my NOx sensors. I don't run them anymore. I don't necessarily recommend that for everyone. The NOx sensors do serve a purpose in the fact that they're going to detect pre-detonation. Think of the NOx sensor, 2 NOx sensors, one on either end. The NOx sensors are like microphones, so they're listening inside the engine to hear any pre-detonation, knocking, pinging, or otherwise it's known, and they will either send a trigger and give you an idea that, hey, you've got some pre-detonation going on. You need to figure out why that's happening. My particular system with the Holly, I chose not to run NOx sensors. I can usually hear it when it's happening, and in my case, it was bad gas. I just upgraded my gas, and it went away. But that's your accessory drive. Your intake's going to be really simple too. You can run the intake that came with it. You can get an aftermarket intake. They'll most likely all have the same sensors and fittings on them. But just to recap, remember you're going to want your throttle position sensor. You're going to want maybe an intake air temperature sensor, manifold absolute pressure sensor, and that's pretty much it. Yes, there's some gray area in between depending on how you build in this thing, but don't worry about that stuff. If you're freaking out about the electronics, the objective of this video is to say don't. It's simple, it's easy, you got this. The intake on an LS motor is very, very different from what you're going to see on an old school carbureted motor, because for one thing, there's no carburetor on here. This is the intake off of my engine, which is an LQ9. This happens to be an LQ4. I went with a Holley mid-rise intake on my build. But I do want to inject this right here, that the truck intakes, although pretty ugly, are fantastic intakes, particularly for the kind of builds that we're looking for, which are usually low power, low in the power band. We need torque, and that's what these guys provide you in spades. So do not overlook the truck intake. It is a fantastic intake, and it's probably one of the best kept secrets out there. People often overlook them because they're not the most attractive, but with these high runners and just the design and the flow, it's a fantastic, fantastic intake. The other benefit you're going to see with the LS is, instead of having a carburetor on top that the fuel gets mixed in the bowl and distributed through the manifold, the injectors are at the base of the runners, and so the fuel is delivered perfectly, just like that spark is delivered perfectly through all the individual coils on top of each cylinder. Same thing, you have injectors on each one. If you think of it this way, back in the day when we were tuning old school carbureted engines, a lot of what we did was to try and improve the spark or improve the fuel. We would do an upgraded spark plug wire, or a hotter spark, or try and get the jets and the fuel to perfectly do their thing. The LS is calculating the fuel delivery on a millisecond timeline. And so it can constantly, based off the readings on the cam position sensor, the crank position sensor, the throttle position sensor, it can deliver the appropriate amount of metered fuel right into that combustion chamber. It's not having to get spread around, it's going straight into that combustion chamber. That is going to give us a much more efficient engine, a much cleaner burn. We're going to get more power with less pollution. It really is very astounding what these guys have been able to, what GM has been able to accomplish out of this engine. With the similar architecture of the old small block Chevys, if you're putting this into a truck or a vehicle that had a small block before, you're pretty much in for a move place. The motor mounts are going to go in a very, very similar place. If you're not doing a traditional small block Chevy replacement, you're doing something a little bit crazier, just check out your specific enthusiast market. I guarantee there are motor mounts made to put this into an E36 M3, for example. The motor mounts that Carl is using do give him the option of moving this guy forward or back for clearance. Maybe you want a mid-mount and you want to push the engine all the way back, or maybe you want to push the engine forward. You have some adjustability with this. These guys are super robust. This is just going to bolt straight up to the original factory motor mount. Very simple, very easy. Do not lose sleep over your motor mounts. Undoubtedly, one of the best things that GM could do was to give us an engine that still bolted up to the vast majority of transmissions out there. And that's exactly what they did. The 700R4 was the transmission that was behind the small block in pretty much every square body. And the 700, the later square bodies. And the 700R4 happens to have the same case as the new 4L65. Now, you will want to upgrade to an electronically controlled transmission to take advantage of the electronic controls available to you in the computer. Moving from OBD1, Onboard Diagnostics 1, to OBD2 was a huge leap forward. It's like, think of like the original Palm Pilot versus the latest iPhone. So definitely take advantage of all of the technology in OBD2, which came with electronic control of not only shift points, but a various bunch of stuff in your transmission. And these new transmissions bolt right up. If you happen to have a crazy transmission that doesn't automatically bolt in, I guarantee you there is an adapter out there. We'll enable you to bolt it right up. Very cool, very simple. I'm glad GM has has basically just shown the enthusiast market that they got us. They know what we're doing, they want to support it, and as a result, they give us stuff that is easy to do that with. I may sound like I've got a mantra here, but this is simple. There's not a whole lot of stuff to go wrong. In fact, I think these are often simpler than the old small blocks they replace. There's no vacuum lines to really worry about. There's no jetting and carb concerns. They're really, really awesome. And you get a ton of power out of them too. Several years back, I did put together a video series called How to LS Swap, and it was very successful and it did well, and I think it was helpful to a lot of you guys. This has been a revisit to that. With my friend Carl putting this awesome engine in his square body Blazer, I thought it gave him the opportunity to kind of stand back and with ungreasy hands film and document everything that he's doing. So if you have not seen my original build series, I'm going to link it up here so you guys can go check that out. It gets a little bit more into the details and gives you a little bit more fine information. This is basically just show you guys that you can do this. You can do it in your garage, you can do it in your driveway. It doesn't need a superior set of skills or a killer amazing set of tools. Just get out there, roll up your sleeves, get greasy, and get it done. Give me a subscribe if this is appealing to you. We'll see you next week. Merricks Garage.